Okay, let's go back to this. Okay, so what I was going to do is a count list. Okay. Okay, so if I do safe model count, and I don't want to do hypergraph plot, I just want to do this. So this here, and now I want to say, instead of Wolfram final state, I want to say, what do I say? States count list, is that right?
I don't think we have it yet.
Thought we had that. Or do I just
Wait, what is states count list?
Oh God, that's for multi-way systems. I'm losing my mind. Let's look at this documentation here.
I mean, we can just do
Length.
States, but then we need to length over it.
States list, right?
Yeah.
Okay. Hmm. Well, it's not totally obvious. I wouldn't count this guy as totally hopeless. But let's see, what is this? What was this case? This case was...
I mean, it's a weird looking universe, but it might do something interesting.
How could we otherwise analyze this? I mean, we could try getting it. And that was what we got before. So what can we do to that picture that will, I mean, we could do if we'd got the neighborhood.
Can we delete the center vertex and see what is left?
How would we do that? What is that center vertex?
Good question.
Well, let's get the result. Let's get the state's final state there.
No, we can find it and then replace it to nothing.
Yeah, I understand. So let's get 5 steps. If I just say comma 5, do I get this final state after 5 steps?
No, you will get evolution object.
Okay, so you say I delete cases all the 0, 0, 0s.
What do you mean? No, I'm saying delete vertex 0 from all edges. Just
But I have
replace
many
0
copies.
goes to nothing.
How do I have so many copies of 0, 0, 0 here? How do I end up with multiple copies of a single vertex? A single edge?
Well, why wouldn't you?
Oh, okay, fine. But what I want to do here, first thing I want to do here is delete cases of just that the central edge.
Well, you can certainly do that, but well, okay.
That wasn't
Does
very
make
helpful.
it much more clear.
Okay, so let's
Yeah,
take that thing and delete every 0 from everywhere, right?
Yes.
That was instructive. So basically, it's just a bunch of these things connected down. Okay, so let's take that thing. Let's take the next step of that. You know, it is really nice having functions that actually work.
Well, I know. That's why
You believe in source code control.
Yes, exactly.
The
No, seriously, without unit tests, it wouldn't work nearly as well. I caught a lot of bugs because of I have sort of manual CI.
Fair enough. All right, so I think this guy is boring. I mean, we can count the number of these little tadpoles that it makes and so on, but I think it's boring. Okay, so your contention is that we need to try larger numbers of symbols.
Yes.
Okay, so let's try 5 symbols then. Okay, hypergraph plot, do your thing. Why is it taking so long? I thought SafeGraph, doesn't it? When does it compute the answer? Oh, it runs hypergraph plot.
Is outside.
Should we time constrain the hypergraph plot as well? Or is that just going to make a mess?
I don't think so.
Humph.
Well, according to my testing, it's less than 3 times slower than graph plot, but maybe this case is particularly bad for some reason.
I agree, there's a lot more juice in these. Okay, let's pick some that we care about. I think that guy looks interesting. Do you agree?
Yeah.
Not sure if I can click more of these. How does this work? Oh, that's just a copy to clipboard. That's kind of dumb. I really want an accumulator here. Okay, well, that guy looks kind of interesting. For some reason it didn't get that one. That one looks interesting. I think that one looks interesting. All right, so let's take them those. All right, so now let's go. Let's try and go like 15 steps for those guys. Okay, what's going to happen next? Well, I think we should try running these a lot longer. Actually, let's do a safe model count. Wait a minute, there are a bunch that just stopped growing. See, these ones just gave up.
Yeah.
However, this guy, when this notebook finally saves, that guy is kind of interesting. What is he doing? He counts in tens. That is really exotic. Look at that. It's a pentadactyl or hexadactyl. Okay, why does that count? Okay, so let's do a... Oh gosh, how do I get this? Did you put in the automatic thing yet?
No.
What the heck did I do? Oh, silly me. That was kind of interesting, though. That's an interesting little picture.
Yeah, it treats every expression as a vertex in that case.
Okay, what is this doing? Well, let's look at the rule. Oh gosh. Let's find out. This is crazy. Look at this thing. Well, I mean, it's just some kind of snake that's extending itself, I think. But it does seem to have some weird properties there. I mean, we wouldn't even know if it was running a solid automaton on the snake.
Well, it looks like it just extends it in both directions.
Yeah, I think so. But the thing has managed, the hypergraph has managed to flip around some of these.
I'm not sure it actually means anything.
No, I'm not sure it means anything either. So let's look at one of these.
I mean, it actually should flip all of them because of spring electrical embedding.
You mean either one, like
They
a
will have
plant
the minimum
growing?
energy if it flips them, you know, alternative up, down, and so on.
What can we see here? You know, I'm going to do something absolutely bizarre. That's not completely uninteresting, actually. That's essentially the adjacency matrix for this thing. It's like it extends its tail in one direction.
Yeah.
Okay, let's keep going. What should we look at next? Should we look at some which have mixed? Do you think more than two rules on the left? Actually, we can try some that are combinations of rules, right?
Yes, we can. Yeah, I think more than two edges on the left would be interesting.
Okay, but so what we want to do here, we don't necessarily want okay, so we want, let's say, well, let's just try three edges on the left, just for fun. Okay, let's just try this to begin with. I should write a thing that accumulates. Let's see, what's the best way to do that? What's the best way to write an accumulator that you have to start the accumulator and then return the accumulator at some point? Not optimistic about any of these. But then we only went 10 steps. So I wonder what I mean, really, probably what we should do is put a spark line underneath it showing the evolution. Okay, that guy looks a little bit more lively. What the heck is it doing? Looks like it's spawning different critters. It's not going to find anything. Come on, die off. Oh, come on. How can find sequence function be a thing that's gone bonkers? Up. Okay. Interesting. It's a lively one. All right, let's try getting another indicator here. Well, it's kind of interesting. It seems to be maybe there it's taking off. I'm not sure. All right, what do we do with this guy? Okay, so let's first of all, that's at 10 steps. Those nodes are very big. Why are the nodes so big? Oh, we can get the causal graph of this guy as well.
Yeah.
Right.
Yeah, so with node sizes, I completely re-implemented the scaling in the new version, which is, I mean, it's not merged yet, but it will always have the same ratio of vertex size to average edge size.
Okay.
Yeah, I think the vertices with large degrees confuse everything. Maybe we should just delete vertices, you know, after given vertex degree and see what happens.
Fine, but let's just try and look at causal graph here. Oh my gosh. Interesting. What does this tell us? I guess we should make that a layered graph plot. That's pretty interesting. And it seems to be
Yeah.
breaking into different pieces, but okay, so let's take I'm just going to do a final state thing here. I'm going to do my crazy thing. What does this mean?
Looks
That's
like
the
there's a
initial.
bunch of lines there.
Yes. I wonder what those lines are. Really would be nice to have hypergraph plot 3D. Did we look at what this rule does? I mean, what do we look at the let's just look at oh, what does that do? Just a second, I'll be right back. I need some food for thought, you know. This is okay, and then we need to figure out what we can do to like prune the thing and see, you know, like one thing we might try to do is see sort of whether there's a backbone of it that does something simpler. Yeah, I'll be right back.
Okay.
Hi there. We probably should try some ordinary graph ones, right? Because we can still get non-trivial stuff with ordinary graphs.
Yeah.
And we should try some that have both growth and decay curves. I mean, rules. Did you figure out what this one does? I mean, also, I have no guarantee that this thing is not deeply affected by its updating order.
Oh yeah, it certainly might be.
Jonathan's code should be able to tell us whether it's causal invariant. It probably isn't.
Try that.
What's that?
Yeah, we can try that. I mean, I've seen it working many times, so it will probably work.
Or, well, we could just look at some other ones. I mean, I think I'll just go back here. So another one here that we think looks interesting. Which was that one? This one? Was it this one here? I think so.
I think so.
That one. I think that one just stopped growing. That's not 15 steps. That stopped. Right?
Yeah.
It's kind of weird that it reached that size and then stopped. Okay. Well, let's try let's just try some ordinary graphs. So we could try hypergraph. We'll revert to ordinary graphs when it can, right?
Well, it doesn't actually do that, but it should still work. I mean, it doesn't do anything special for normal graphs.
Okay. Okay. So what we want to do, let's say 3, 2, 7, 2, 5 symbols. Gosh, there's some pretty non-trivial things here. Quite non-trivial, actually. How surprising. Oh, why does it have polygons that are filled in here? Is that a bug?
No, it's not a bug, because if the edge is a multi-edge, it's convex polygon is, extends to the middle of it as well.
I see. Okay, well, so there's multiple things here to look at. Gosh. Like that guy. Let's take a look at that guy. And then I got that the wrong way around. Yeah. Okay. So here I can say that's really weird. Look at that. Now let's look at the rule. That's funky. So here, so I could just use graph plot by just saying graph plot rule at that. Oh my God, what is it doing? I just got messing involved a bit longer. Okay, what is this thing doing? The hell is it? What is it? And what's its dimension and so on? What's that going to turn into? Look at that. What's that? Let's see if we can get this to 40 steps. That's very fast. Well done. Let's get it to 50 steps. Okay. Hello, weird creature. All right, a little dangerous, so let's get it to 100 steps. That was really nice and fast. Oh God, this is weird. Okay, if this goes up exponentially, then the creature is some kind of weird binary counter. One, 2, 6, 8, 72. Know what that is?
Not really.
I don't know either. I mean, that's kind of odd that it goes all 72 steps there. Okay, so let's take. Do you know how to get GraphPlot 3D not to try all that fancy nonsense?
Not really, but maybe some way to do it.
You're hard to hear, by the way. This is fun. Look at this guy. What is that? Hard to know what this guy is.
Why does large graph has to be red?
I haven't a clue.
What?
I haven't a clue. All right, let's see what else we can figure out about this one. So, I mean, this is interesting because it means that even It's really kind of interesting that even this thing, which is sort of a trivial, let's look at that guy. See if that guy stops growing. That's dead. We didn't try this one, did we? This is not very efficient what I'm doing here, but oh boy. It's kind of amusing. It's really amusing. I wonder whether the creature will grow any more arms. It says with, I mean, I wonder whether it's, how many arms does it have? Does it have 1, 2, 3, 4, 5, 6 arms? Oh, what is that, a hex? But what does that make it if it was in the animal kingdom, so to speak?
Hexapod, I guess.
I know it's a hexapod, but is that a spider, an arachnid? What is it?
No, arachnid should have 8.
I always forget how many these have. So what has 6?
I think it's called hexapods.
I know it's hexapod, but look at that guy. What a weird thing. What a totally weird thing. This is so weird. I wonder what the causal graph of this. I won't call it a puppy because it really isn't one. This cockroach. No, is it a I don't know. How many legs does a cockroach have anyway?
I think 6.
Okay.
Not completely sure.
Okay, that's weird. What does it mean that its causal graph looks like the thing itself?
Well, I think it means it's split into 6 pieces that don't interact with each other.
Fair enough. Fair enough. All right, so what this tells us is that we've already got non-trivial stuff happening with just graphs with 3 input graphs. So let's take a look. I mean, we've clearly already got, I mean, that's clearly a non-trivial example. Whatever this is, that's clearly something non-trivial is happening here.
Yeah, well, I mean, our favorite one from a year ago also has only 3 inputs.
Has 3 inputs?
I think so.
What does it make?
Well, it makes this complicated thing that you've seen many times before.
But it doesn't seem to be a manifold, right?
Well, not completely sure, but it doesn't look like it. Well, I don't know. Might be.
Okay, well, so let's look. So let's cut down the complexity here. Let's just have 5 of those. Okay, and 4 symbols. Now, I think nothing interesting is going to happen, but let's find out. The basic principle of this kind of investigation is the animals are smarter, always smarter than you are, even the ones with 6 legs. Okay, there are already some slightly non-trivial things here. So let's take a look at the ones that might be non-trivial. That guy. That guy, what do you think about that one? I think that one's going to be trivial.
Yeah.
Okay. That's odd. Oh my God. What the hell is that thing doing? What is that doing?
So given that number of events is the same as number of generations, it looks like it has a pointer, but not obvious what it is.
That's a Turing machine of some kind.
Yeah.
Unless it just exploded. It's a fish. I don't know. We're always going to see animals in these. Okay. Right, so that one is, it's amusing, but it's just a fish. And of course, these things might have better behavior with other initial conditions, but we don't know that. Okay, that's a little bit more states. Ooh, interesting. Manifold, I think. All right. We're going to make it to 40 steps. So looking frilly there.
Oh, it kind of looks like a spider web to me.
Yeah, which would be good because it's two-dimensional.
Yeah.
It's completely unobvious how you weave a two-dimensional thing, but I have a bad feeling it's going to be more like a lettuce leaf than a spider web, and exponential, exponentially frilly. Humph. Well, that may have been a mistake. Maybe I should have done the whole safe model thing.
I mean, you should be able to abort it.
Yeah, I know, but it seems a shame. So much for the aborting. I tried to abort, it didn't abort.
Oh, that's interesting.
Humph. Well, the basic conclusion here is that, so let's see, so even without hypergraphs, we're getting non-trivial things happening.
Yeah.
Which is interesting. So I wonder how these relate. I mean, you had previously, so you had to use hypergraphs to reproduce the colored network results that we had before, right?
Yeah. I mean, it makes it much easier.
Okay, well, what do we do with this? We'll have to kill it, I think. That's annoying. I guess we have to kill it. I don't see any other choice. Do you?
Yeah, I don't know what's going on here.
Oh, I think it's time for me to go to sleep. So I bet that this is a reasonably enumerable number of things. So we really, I mean, I have previously been going up from the most simple cases, and I think we need to look at that more carefully and figure out, right, for these with simple initial conditions, yeah, I'm getting tired. All right, well, I'm just going to leave this just for fun overnight and see what it does.
How come I can abort it? So
I don't know.
I'm running the same thing and I can abort it. And it aborts pretty much immediately.
Oh, don't tell me my abort thing is broken again.
So my version is November 3rd.
Well, that didn't do anything there.
Maybe I should try running longer before aborting. Yeah, after running it for a minute, it takes a bit longer to abort, but I still abort it within a second.
Sure, it's interesting that quite a few of these like spray things. So these are ones where there's disconnected pieces.
Yeah.
Yeah. And by the way, it's kind of interesting. This is obviously a one-dimensional object, basically, as was our crazy spider creature.
Right.
So the question is, do we get, I mean, it's clear we can get exponential growth. The question is, do we get polynomial growth in between? I think it's going to help a lot when there are some rules that reduce the size as well.
Yeah, probably.
All right, it's time for me to go. Well, okay. All right. This is looking really nice. Well done. Thanks. Yeah. So it would be nice, by the way, for hypergraph. Shouldn't hypergraph plot just, in the case where it finds it's just given an ordinary graph, just do the ordinary graph thing?
I'm not sure. I think it's better to make it consistent. It does the same thing every time.
All right. But I mean, can't it do? Yeah. Okay. Fair enough.
Because one thing I don't like very much with graph plot is that it has a lot of different cases. So I can never know what to expect from it.
Yeah. No, I agree. For these purposes, that's bad. All right. Okay. I got to go to sleep. To be continued. Talk to you soon. Okay. Thanks.
Okay, see you.
Okay. Bye.
Bye.